At regular intervals, a dark opening passes through the planetary group, likewise passing through the Earth. Why have we not seen this before? It's because of the exceptional nature of these dark openings. Dissimilar to the monsters in the centers of galaxies, these dark openings eat stars but do not destroy planets. Early-stage dark openings might be like remnants of rudimentary designs of the universe. It sounds insane, but dark openings are continually flying through the solar system, and potentially even directly through us, without us even noticing them. But how is that possible? Scientists claim that small dark openings have been flying through space since the beginning of creation and are present nearly everywhere. Here on Earth, between planets, among stars, and in galaxies. These dark openings are so small that we have neglected them up until now. Early-stage dark openings are no bigger than a particle, so we would never see them with our own eyes. Even scientists can't actually see them with their best magnifying lenses, but they assume their impacts. A particle weighing an asteroid. What happens when a little dark opening passes the Earth? In principle, these dark openings are so small and so sparse that they don't directly interact with most matter particles in their environment. Despite their minuscule size, these dark openings have incredibly high density and thus apply a strong gravity for their size. One of these mini openings can weigh as much as an asteroid, and these pieces could rapidly weigh several hundred kilos or even tons. Despite their weight, scientists agree that early-stage dark openings can pass through the Earth without causing huge harm. The theory is that, due to their tiny size, they are unlikely to interact with ordinary matter. However, a dark opening passing through the Earth wouldn't be without impact. The dark opening would cause a tiny local change in gravity. Despite its weight, this would be so small that it would barely be measurable, due to its tiny size and the low likelihood of direct interaction with atomic nuclei or other matter particles. The dark opening would go through the Earth without consuming any matter. However, theory suggests that these many dark openings are not a coincidence and might play an underrated role. Early-stage dark openings are believed to have formed right after the Big Bang, when extreme density variations occurred in the chaotic early universe. Some scientists suspect that these early-stage dark openings could be part of dark matter. If this assumption is correct, they would be a significant part of the universe. After all, dark matter is believed to make up around 87% of the currently known universe. Probable hints of dark openings could be small disturbances in the Earth's density distribution or minor movements in the landmasses. This raises the question of whether these impacts are actually not disturbances at all but rather a major part of the functionality of matter. The properties of dark matter are still not fully understood today, and we don't even know for sure that it exists. Scientists use dark matter to explain effects and phenomena within the universe that can't be explained by observable forms of matter. If the hypothesis of many dark openings traveling through the universe is right, they would give us a significant clue about whether dark matter truly exists. Scientists hope to soon be able to prove the presence of early-stage dark openings in our solar system and near Earth using highly precise measuring instruments. If they succeed, we would have the first direct evidence of dark matter's existence. Consequently, our astronomy would make a huge leap forward. Right now, our entire cosmology is being questioned, and some scientists suspect that dark matter could be to blame for errors in our understanding. If dark matter doesn't actually exist, our cosmology has been based on a false assumption since the 1970s. But if the tiny dark openings confirm that dark matter exists, scientists will be able to confidently assert that their old theories and ideas were right. What harm, in reality, do dark openings do to Earth? We are dealing with an unsettling truth. Our science shows us over and over that it doesn't know everything, and we must face the fact that science can also mislead us. The simple truth that the phenomenon of small dark openings is so difficult to prove raises any statements about their true impact on Earth as pure theory. Some scientists assume that early-stage dark openings are an anomaly and reassure us by saying that the likelihood of such a dark opening directly hitting or passing through the Earth is very low. Space is said to be vast, and in comparison, small dark openings are considered rare and scarce. However, other scientists believe that these tiny entities could happen much more frequently and are even a fundamental part of the universe. Some studies do not rule out theoretical dangers. If such a dark opening were to pass very slowly through the Earth, it might actually attract matter from its immediate area, thus adding to a vulnerability in the stability of the Earth's matter. Critics of the Large Hadron Collider in Geneva repeatedly claim that dark openings are being created there. This might be done intentionally, but it's also possible that dark openings emerge as a byproduct of the tests conducted in the world's largest atom smasher. Scientists shoot small particles of matter at each other at high speeds. When they collide, the matter breaks down into its part pieces. Scientists need to study the nature of the subatomic parts of matter by examining their behavior and the forces that arise from these particles. These particles aren't exactly visible to scientists, they can only observe their effects. That could be the danger. During these tests, the fabric of matter could be shaken, and forces may be produced that we don't yet fully understand or measure but could potentially affect visible matter, much like many dark openings. People in Geneva are supposedly playing God, and critics argue that the tests have long since created layered entrances or that dark openings created as a byproduct are changing the fate of Earth without us even realizing it. Similarly, the small dark openings could play a role in the general construction of matter and creation that we've misunderstood. Early-stage dark openings, as well as their origins, are now believed to travel through the solar system about once every few centuries. Although they apparently cause no noticeable effects or apparent destruction, their gravity is supposed to be strong enough to cause minor changes in the orbits of planets or other objects. Since they emit no radiation, these dark openings are invisible and must be detected through their gravitational effects. One possible detection could be through tiny wobbles in the orbit of Mars. These small changes are observed by high-accuracy measuring instruments. Thanks to advanced technologies, such as Mars rovers and orbital measuring devices, scientists have been able to measure even small changes of a few centimeters over years. Studying such objects could give insights into the conditions of the early universe and expand our understanding of gravity and matter. If these dark openings were present billions of years ago, they would serve as witnesses to a precious era. Should it turn out that they follow a pattern or a particular function, these early-stage dark openings would be another key to understanding the blueprint of the universe. Regardless of the latest investigations, questions remain about whether the theory of small dark openings can truly hold up. The effects, like the waves or variations in the Martian orbit, are minuscule, which requires a high degree of precision in the measurements. Moreover, the effects could also be triggered by something else. The search for the currents of wormholes is an exciting aspect closely linked to the theory of early-stage dark openings. Theoretical physics describes wormholes as hypothetical connections between two different points in space or even in time. These tunnel-like structures could make it possible to cover vast cosmic distances in seconds. We know the concept from sci-fi movies, but few people realize that even recognized science affirms that wormholes really do exist. Some researchers now suspect that the tiny early-stage dark openings could be a type of microorganism cell for wormholes. The idea is both crazy and captivating at the same time. It's based on the fact that space-time around dark openings is so severely distorted that it might create the conditions for a stable wormhole to form. If such structures exist, they could not only radically change our view of the universe but also explain how matter and energy are transported between distant areas of the universe. If we imagine that such wormholes exist not just in distant galaxies but also directly within our solar system, the idea takes on a whole new dimension. Imagine that early-stage dark openings, which regularly pass through our Earth, are in fact tiny wormholes. Then, there could be direct contact with other regions of the universe or even parallel times and universes, all within our environment. Although this idea is still formally treated as pure theory, scientists are actively searching for signs of such intriguing phenomena. One hope comes from gravitational waves, which could provide clues as to whether transitional dark openings exhibit serious proof of a wormhole in their structures. Subtle differences in the signatures of the waves generated by events like black hole mergers could uncover the presence of layered and time doors. Even Albert Einstein believed that wormholes were possible. His research in the 1930s, combined with that of Nathan Rosen, prompted by the possibility of the Einstein-Rosen bridge, this is a numerically unquestionable passage that could hypothetically connect two far-off points in the universe directly. The genuine confirmation of wormholes wouldn't just be a momentous scientific discovery. As for practical applications, you can imagine advances in the exploration of the universe. Wormholes might offer us contacts in different realities, and some hope that research will lead to advances in the development of space travel. Spaceships could use wormholes or folds in spacetime to overcome the vastness of space and take us humans far beyond the limits of the solar system in ways we never imagined. Subscribe to the feed now. Awesome videos are on the way.